The standard deviation formula in Google Sheets is a really easy formula to enter, but you need to make sure you understand what it is to be able to use it properly. And it's mentioned in a few other videos, so I thought it would be important to share with you what the standard deviation means. Now, we're not going to go over the actual formula of how to calculate this, since we have the formula to calculate it for us right in Google Sheets. However, you don't need to actually be able to calculate it with the formula to understand what it means or what it represents. So just before we start, I'm going to show you exactly what the formula is. So it's just equals StDev and then the range that you're wanting to calculate. So over here I have data 1, data 2, and data 3 with the standard deviation and the average of each. So it's the standard deviation and the average of each of these data sets. Now, one thing I want you to notice is how different each of these data sets are. But notice the average. It's 5 for every single one of the data sets. An average is usually a pretty good number to give us a good picture of what the data looks like, but it's not a complete picture. And we're going to see that as we learn a little bit more about the standard deviation. So if you look over here at your data set, so data 1, we have, and actually this number line right here, it represents data 1. And then we have data 2 and data 3. Remember, they all have the same average. But if we look at the standard deviation, it's different. So what does it really mean? Well, I'm going to show you using this number line. So if we look at this number line, the data, our average is right here, right? So here's our average right here. And our data points are marked in red. So I'm going to measure the distance. So the distance from this data point to our average, and the data from this data point to our average, each of those is 1, right? And this data point right here is 0 away from our average. It's right on our average. Well, then I'm going to measure this data point, and it's, oh whoops, and it go all the way to my average. So 5 up to 9, it's got a distance of 4, right? And then there's another data point that same distance. And I'm not going to do this with all of these, but I just want to give you some perspective of what the standard deviation is measuring. So if I were to take all of these measurements and I would do some calculations with these measurements, it would spit out my standard deviation if I followed the proper calculation. But what it's telling me is how much, on average, do my data points deviate from my average. So how close are they to the average? How closely clustered are they? So that's why if we look at each of these data sets, by seeing the standard deviation and the average of data set 3, I can tell the average is 5, the standard deviation is 0. That means every single data point in that data set is 5 because it deviates 0. And sure enough, if we look at my data set, that's true. Data set 2, again, the average is 5, standard deviation is 5. So on average, each of the data points deviates by 5, which if we look at our data set, that's pretty true. Because the average is 5, we have a 10 and a 0, which are both 5 away from our average, and then we have a 5. So it's not going to tell you exactly, but again, it's an average, because it can't tell you the deviation for every single data point. And then here we have a standard deviation for our data set 1. On average, we deviate about 3.3 values or measurement away from our average. So it kind of gives you a sense. If you had a standard deviation that was 10 and the average was 5, you would know that your data points deviate a lot compared to our data set 1. So it gives you more information about a data set than just the average.